Hi guys, today we are going to be solving exponential equations. But the question is, what is an exponential equation? An exponential equation is an equation that has a variable in the exponent area. So something like 2 to the x is equal to 4. Okay, why is this an example of an exponential equation? Or why is this an exponential equation? So this is an exponential equation because you said it, there's an exponent, there's a variable in the exponent area. To solve exponential equations, we are hoping that we can use the property of exponential equations, or the property of equality of exponential equations. The property of exponential equations says this: if b to some power equals b to some other power. Okay, so if b to the x equals b to the y, then x equals y. Okay, I'm not gonna pretend like you got that. Okay, I don't even get it. Okay, so to solve exponential equations, we are hoping that we can use the property of equality of exponential equations. Okay, so pretty much someone said, do we have to memorize if b to the x equals b to the y, then x equals y? No, like I don't. Okay, I think it's more of an understanding. Okay, so let's go ahead and break it down. So this is saying if you have an equation, so left side equals right side, what do you notice that is the same? Okay, the basis. Okay, base on the left equals base on the right. So the property of exponential equations, what that says this: if the bases are equal, then there's no way around it. Then the exponents have to be equal. Okay, if the bases are equal, or they're the same, then there's no way around it. The exponents have to be the same. Why? Because we have an equation. The left side has to equal the right side. So if the bases are the same, then the exponents have to be the same. So let's go ahead and do a quick example or illustration. So let's just say we have 5 to the x is equal to 5 to the second power. So you can evaluate this to 25, but I recommend that you leave it as 5 squared. So then I'm like, okay, how am I going to solve this? I want you to notice what is it that is the same. So it's like, oh look, the base on the left is equal to the base on the right. Okay, so the property of exponential equation says this: if the bases are equal, there's no way around it. Then the exponents have to be equal. Okay, if the bases are the same, then the powers have to be the same. I'm going to try to keep saying the word equal. Okay, so if the bases are equal, then the powers have to be equal. Okay, so then we set the powers equal to each other. So left exponent equals right exponent. We look at our resulting equation and solve it. For this problem, we got pretty lucky that just by applying the property of exponential equations, we're done. Okay, but if the variable was not isolated, then we gotta do a little bit more math. So now we're gonna wrap up this video by 3 cool problems. We are gonna be asked to solve these 3 equations, and you guessed it, they're all gonna be exponential equations. So the question is, how do we solve them? You can read the guidelines, but I'm gonna tell you the guidelines as we do our first problem. Okay, so the problems are typed up, so there's no surprise. I'm just gonna write each problem one at a time. So we have 2 to the x equals 16, and I know you're awesome. You can just do it by inspection. You're like 2 to the first. You could be like 2 to what power is 16? 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. But I would prefer if you show me your algebra. Okay. So then the question is, how are we gonna solve? Well, first question, what kind of equation is this? Is it a linear equation, quadratic equation, rational equation, radical equation? What kind of equation is this? So new to our life, where's the variable located? The variable is located in the exponent area, so I guess we have an exponential equation. The question is, how do we solve this bad boy? Ideally, we would like to fix it so the base on the left side equals the base on the right side. Why? Because pretty much we want to apply the property of exponential equations, where we will say if the bases are equal, then there's no way around it, then the powers have to be equal. So let me go ahead, just speak to myself, write a little love note. So I'm like, okay, goal number 1, fix it so the bases are the same. Okay, the base on the left is 2 and 2 is a prime number, so you can't break it down, so it's pretty much 2 or bust. The base on the right is 16, but I'm gonna ask myself, can I fix it so we can write it in terms of base 2? And I think we can, because 16 is the same as 2 to the 4th power. Okay, love no time. So step number 1, how do we solve an exponential equation? Our first goal is to fix it so the bases are the same. In this case, we're going to aim for base 2. We have base 2 on the left, so we're good. Let's go ahead, write 16 in terms of base 2 or a power of 2. You prime factor 16 and that will give you 16 is the same as 2 times 2 times 2 times 2 or 2 to the 4th power. So now the question is, how are we going to solve it? We're like, okay, we're going to ask ourselves, are the bases the same? I hope so. Okay, so what do I notice that's the same or equal? In this case, the bases are equal. So let's go ahead and apply the property of exponential equation. So remember, the property of exponential equation says this: if the bases are the same, then there's no way around it. Then the powers have to be the same. Okay, so if the bases are equal, then there's no way around it. Then the powers have to be equal. Okay, we're going to pretend you can read that. That says equal. Okay, so that will give us that the left exponent equals right exponent. Fantastic. We solved this new equation, but lucky for us, the variable is already isolated, so we're done. So one problem down, 2 more to go. Problem B, we have 2 to the x power is equal to 1/8. 2 to the x power is equal to 1/8. So let's go ahead and ask ourselves, what kind of equation is this? Where is the variable located? Once again, the variable is located in the exponent area. So it's like, oh, exponential equation. How are we going to solve it? So ideally, we want to fix it so the bases are the same. We want to fix it so the base on the left equals base on the right. Now, 2 is a prime number, so there's no way we can rewrite it like 16. We could rewrite it in terms of base 2. 2 is a prime number, so it's once again it's gonna be base 2 or bust. Okay, 8. I'm gonna go ahead temporarily ignore that it's in the bottom and we can bring it to the top. But 8, last time I checked, 8 is also a power of 2. Okay, so let's go ahead aim for base 2. So we want to fix it so we have base 2 on the left and base 2 on the right. So the left side is already a winner. We have base 2. The right side is not quite base 2. Let's fix it so it is. Okay, so 8, if we prime factor it, is the same as 2 times 2 times 2. So we have that 8 is the same as 2 to the 3rd power. So we got base 2 on the left, not quite base 2 on the right, but we're getting there. At this point, we're going to use the negative exponent rule in reverse to bring the 2 to the other side of the fraction bar. So let's go ahead and do that. So let me go ahead and bring down the left side. So we have 2 to the x equals, we're going to move the factor of 2 to the other side. And anytime we move a factor to the other side, we're going to switch out the exponent. Usually we only move the factor when it's being raised to a negative power, but in this case we need to bring it up so we can have base 2 also on the right. So now I'm going to ask myself this. Are the bases the same? We got base 2 on the left, base 2 on the right. Let's do this. Let's apply that property of exponential equations. So remember, the property of exponential equations says this: if the bases are equal, then there's no way around it. Then the powers have to be equal. Okay. Alright. Okay, so if the bases are equal, then the powers have to be equal. Fantastic. Alright, so I had a little moment to myself because this is not the answer that I was thinking off the top of my head. It is a good problem, but it's not a problem that I wanted to illustrate. So let's go ahead and do a brand new problem C. So this will be problem D. Okay, problem C, we have 8 raised to the x power is equal to 2. Cool. So there's a reason for my madness, so trust me. Okay, so problem C, 8 to what power equals 2. Okay, so first, I'm going to ask myself, what kind of equation is this? So I'm like, okay, where is the variable located? The variable is located once again in the exponent area, so we have an exponential equation. So I'm like, all right, cool. How are we going to solve this exponential equation? So I'm going to cross my finger and fix it so the base on the left equals base on the right. Base on the left is 8, but 8 is not a prime number, so we could probably write it in terms of another number. 2 is a prime number, so it's going to be 2 or bust, okay? So in this case, we're going to aim for base 2. So to solve an exponential equation, step number 1, fix it so the bases are the same, okay? So 8 is a power of 2. It's the same as 2 to the third power, okay? So what's going on with the 8? Okay, so we have 2 to the third, or 8. What's going on with the 8? It is being raised to the x power. Okay, so let's go ahead and raise it to the x power. We have 2 on the left, 2 on the right, but it's not quite base 2. The base is 2 to the third. At this point, we're going to use the power rule for exponents from back in the day to raise it to the x power. So a gentle reminder. How does the power rule work? The power rule says this: if you have a factor and you raise it to some power, how are you going to fix it? You're going to keep the base and multiply the exponent. So let me go ahead and do that as a good thinking area. Okay, so power rule, how are we going to fix it? You're going to keep the base and then you're going to multiply the exponents. Product of 3 and x will give us 3x. Fantastic, and that will give us the right side. So now, to solve an exponential equation, how are we going to handle it? Our first goal is to fix it so the bases are the same. Base on the left equals base on the right, and we totally did that. Oh, I missed baseball. Okay, so how are we going to solve it? Since we fixed it so the bases are the same, now we're going to go ahead and apply the property of exponential equations. Okay, the property of exponential equation says this: if the bases are equal, then there's no way around it. Then the powers have to be equal. With your permission, I'm going to highlight the exponent on the 2. That's going to be 1. So if the bases are equal, there's no way around it. Yeah, remind me not to write so much next time, okay? So if the bases are equal, then the powers have to be equal, okay? So the left exponent equals the right exponent. We take our time, do what we gotta do to solve this equation. To get rid of the times 3, let's go ahead and divide both sides by 3. And that will give us x equals 1/3. Cool. We pretend we checked it at our house. But you know what? Sometimes I get a little bit nervous and I second guess myself, which is a terrible habit. So let's go ahead and use our calculator to check the answer. Hopefully you don't have too much brightness. Okay, so to check it, we want to make sure that the left side equals the right side. So we have 8 to the x power should equal 2. So we have 8. Let's go ahead, punch it in. Yeah, turn on calculator. Okay, cool. And then we're going to use the exponent key. Where are you, exponent key? Okay, depending on your model, your exponent key may look like the caret key, which looks like a little house, or it may be y to the x, or I don't know what else. Okay, but mine's, we're going to go ahead and use that exponent key, and we're going to raise it to the 1/3. I'm going to show you the popular mistake in terms of how students punch it in. Okay, the student says, oh, it's 1/3. I myself don't use the fraction button a lot, so I enter the fractions as division problems. So we're going to put 1 divided by 3. So remember, I gave you the warning. I'm entering it how students do it wrong, like the popular mistake. So I don't think we made an algebra mistake. So I know that 8 to the 1/3 needs to give us a 2. Okay, so if it's not going to give us 2, I'm going to start crying. And then it's like, oh, it doesn't give us 2. Okay, why not? I know that we nailed the algebra, so it may be the case that I entered it incorrectly on the calculator. But what's going on? So we have 8 raised to whatever follows that exponent key. That's gonna be the exponent. The calculator knows nothing. Okay, the calculator only knows what you tell it to do. So let's look at what we punched in, or what I punched in by mistake. So we have 8 raised to what follows the exponent key, just the 1. Okay, so what the calculator is digesting is this: 8 to the first power, which simplifies to 8, and then they'll divide it by 3. So they didn't really raise it to the 1/3. So let's go ahead, clear this, and I'm going to show you how to punch it in correctly. So we have 8 exponent key, And the only way the calculator is going to know that you're going to raise it to the 1 divided by 3 is if you wrap it up. So let's go ahead, open the fraction. Then we're going to hit 1. As I say, yeah, divided by 3. And then we're going to close that fraction. Okay, so now what follows the exponent key? In this case, the entire 1/3 follows the exponent key. So now the calculator is reading, oh yeah, you want me to take 8 and raise it to the 1/3 power? No problem. I know that that's going to give us 2. Okay, the worst thing you can do to yourself is nail the algebra correctly, but then when you check your answer, you think your answer is wrong because you punched it in wrong. So just be careful. Okay, so that was our third problem. That was the impromptu problem. The reason why I wanted to do this problem is just to show you how to use your calculator. Okay, let's go ahead and do our fourth and final problem. Maybe I can squeeze it in here. Okay, save a tree or two. Problem D, we have, where am I? 16 raised to the x power equals 1/32 or 1/32. Okay. Base on the left is 16, base on the right is 1/32. But in this case, I don't think we can write 1/32 as a power of 16, so base 16 is not going to fly. Oh, sorry, I jumped the gun on a couple of words. So what kind of equation is this? Where is the variable located? The variable is located in the exponent area, so we have an exponential equation. How are we going to solve it? Step number 1, fix it so the bases are the same. Okay, so that's like the little prep work. So 16, if we aim for base 16, there's no way that we can rewrite this fraction as a power of 16. But last time I checked, if we prime factor the 16, that's going to give us a product of a bunch of 2's. Okay, so we're going to go ahead, aim for base 2. So 2 is the number of the day. I feel like I'm on Sesame Street. Yeah, I'm not going to sing for you. Okay, so let's go ahead, write both the left side and right side in terms of base 2. So last time we checked, 16 is the same as 2 to the 4th power. What is going on with that 16? Oh, it's being raised to the x power. Okay, on the right side, we know that 32 is in terms of base 2, it's going to give us 2 to the 5th power. Some of these numbers I have memorized, not because I want to memorize them, it's just because we do them so much. But what if these numbers don't come to you? It's no big deal. Okay, prime factor it. Okay, go ahead, do the factor trees. Hopefully I'm doing this right. So again, memorize only what you have to, but try to digest as much as you can. Okay, if you want to show work, go for it. Okay, so that will give us 2 to the 5th power. 1, 2, 3, 4, 5. Alright, cool. So we have the 2's in the left, 2's on the right, but it's not quite base 2 on each side. So on the left side, let's go ahead and use the power rule for exponents to raise the left side to the x power. So power rule, gentle reminder, how do we handle it? We're going to keep the base and multiply the exponents. Power rule on the left, we're going to keep the base of 2, and then we're going to go ahead and multiply the exponents. So that will give us 4 times x. So we got base 2 on the left, we want to get base 2 on the right. So on the right, we got 2 to some power, but we don't want it in the bottom. So let's go ahead and use, once again, the negative exponent rule in reverse to bring the 2 to the other side. Okay, so gentle reminder, whenever we move a factor to the other side of the fraction bar, we got to switch out the exponent. Okay, so we move the factor of 2 to the other side, we switch out the exponent, that will give us -5. Sorry, but when you're out of space, you're out of space. So at this point, how are we going to handle it? So I'm going to ask myself, did we fix it so the bases are the same? And the answer is yes. Base on the left equals base on the right. So the moral of the story, remember the property of exponential equation says this: if the bases are equal, then there's no way around it, and the powers have to be equal. Okay, if the bases are equal, then the powers have to be equal. So left exponent has to equal the right exponent. At this point, we're going to solve the resulting equation and then take it from there. So to get rid of the times 4, let's go ahead and divide both sides by 4. And that will leave us with x equals -5/4. Someone said, do we have to write it as a mixed number? It's a personal choice. Someone said, can I write it as a decimal? Yeah, go for it. Remember, decimals are fine, but I kindly ask that you don't round unless you're instructed to do so. Okay guys, I promised you 3 problems. We end up doing 4. It's okay. See you at the next video. Thanks.